Parallel combination of capacitor. 4 marks important. Okay, how to connect the parallel combination of the capacitors? We have to take the three capacitors. Three capacitors. This one is first one C1. Second capacitor is considered to C2. And third capacitor is considered to C3. How to connect the capacitors in parallel combination? This one is plus Q charge Q1 minus Q charge of the second plate. This is Q2 minus Q2 plus Q3 minus Q3 of the second plate of the capacitor. How to connect the parallel combination of the capacitors? First plate of all the capacitors. First plates of the all the capacitors is connected to common terminal. Connected to common terminal. And second plates of the all the capacitors. Second plates of the all the capacitors is connected to common terminal. These common terminals are connected in opposite terminals of the battery. The total potential drop V is same at all the capacitors. That is V. Potential drop is same at all the capacitors. Okay, right. What is change here? The charge is changed. Consider the three capacitors of the capacitances C1, C2, C3. Or apply the charges plus or minus Q1, plus or minus Q2 and plus or minus Q3 respectively. Okay. What is the formula for capacitor? C is equal to Q by V. Then V is equal to, Q by C. Then also Q is equal to CV. Okay. Here charges is different in all the capacitors. First plates of the all the capacitors plus Q and second plates of the all the capacitors is minus. Okay. Q. What is the difference here? Potential drop V is different. Okay. Potential drop V is same and charges is different. What is the charge formula? What is the charge formula? Charge Q is equal to charge. What is the charge Q? Charge Q is equal to sum of charges all the capacitors. Charge Q is equal to charge is equal to sum of charges in all the capacitors. In all the capacitors. Okay. What is the charge? Q is equal to Q1 plus Q2 plus Q3. This is the answer to equation number 1. Okay. But from the capacitor formula, Q is equal to CV, then C is equal to Q by V. We can write the Q is equal to CV, then Q1 is equal to C1V. Here potential drop is same. Potential drop is same. That means V is same at all the capacitor. That's C1V plus and Q2 is equal to C2V. Again Q3 is equal to C3V. Substitute down these values in above equation. That is Q is equal to Q1 means C1V plus Q2 means C2V plus C3. Here, which one are common? V is common, right? V into C1 plus C2 plus C3. That is Q. Here, Q is equal to. Here, charge is equal to. The charge is equal to capacitance of all the capacitors into potential. That means that is Q is equal to CV. Equation number 2. Substitute the value in above equation. Okay. But Q is equal to CV. Substitute the value in above equation. Q is equal to CV is equal. V is common. That means C1 plus C2 plus C3. VV cancel. Remaining value is C is equal to C1 plus C2 plus C3. This is the parallel combination of the capacitors. Equation number 3. For any number of capacitors connected in parallel combination, we can write for any number of capacitors. Formula Cp is equal to C1 plus C2 plus up to so on Cn. Okay, this is the number of capacitance of the parallel combination of capacitors. Okay.